Okay, hello everybody. So we're going to do a couple of problems from section 8.4. 8.4. So I've written down number 23. A woman leaves home and walks 3 miles west, then 2 miles southwest. How far from home is she? There is another question. I'll write it down a little bit later on. So how far from home is she? So just to remind you, I showed you this in another, the previous videos. This is north. Okay. So this is north, west here, east and south. This is northeast. Here's northwest, southwest, southeast. Just to let you know, this is 90 degrees. So here you have 45 degrees, 45 degrees, and so on. All right. And so this is what we have. The woman leaves home. So this is her home right here. And she goes, she walks 3 miles west. So in this direction. And that will be 3 miles, right? And then 2 miles southwest. So in this direction. So this is direction here. In southwest here, it's 2 miles, right? How far from home is she? So you have this walk and this walk. How far is she? This is how far she is right here. This is 3 and this is 2 miles, and we need to find this length right here. How do we do that? We're not going to be using vectors the way they've done it in the book. We're going to try to use the law of sines and law of cosines. And here we have 2 sides. The thing is, we don't have an angle, but we can find an angle. If you take a look here, here you have the angle right here. What is that angle? And that's what you need to find out. So you can say this is 45, 45, 45. So 45 times 3 is 135. Or you can think about it, this is 90 plus 45. So this angle right here is 135 degrees. Everybody with me here? So this is 90. And this is 45. So this will be 135 degrees. So let me make this is not large enough. So this is 3 miles, this is 2 miles, and this is 135 degrees. What do I have? I have side, angle, side. I can use the law of cosine. Remember that? So they want to know how far from home is she. So they want to know the length of the side right here. So if we call this A, if you recall the law of cosine, what is the law of cosine? A squared equal B squared plus C squared, the other 2 sides, minus 2 times B times C cosine alpha. Alpha is the angle opposite the side. So in this case, alpha is 135, right? So A squared becomes B squared. What's B squared? If you want to call this B and this one C, that's fine. So B, C, so that's B squared, that's 2 squared, plus 3 squared, minus 2 times B, that's 2, times C, that's 3, cosine 135 degrees. So make sure your calculator now has a degree mode, okay? Make sure you have a degree mode just like I have here. So you can go ahead and get the answer. You can actually this was simple enough, so I did it by hand, and this is none other than 9 plus 4, that's 13, minus 12 cosine 135 degrees. And that will give you a square. So go ahead, plug it in the calculator. All you have to do is you type, it's 13 minus 12 times cosine 135. So you just type this, and you get what? 21.48528, that's approximately. Remember, this is a square, so you need to take the square root of that. Please go ahead and take the square root of that. If you do, then I just got 4.635 miles. So the woman is 4.635 miles far from home. Now the second question, it says, in what direction must she walk to head directly home? Okay, so you have, this is the graph. Let me graph it again. So here we have 3. I'm having trouble here. This is 2. This is 135. We just found this to be 4 point, you can round it to 4.64 miles. Now they want to know in what direction must she walk, go ahead. So she's gonna have to walk in this direction, north of east. So she's gonna have to go north of east, but we need to find the angle. How many degrees from there? So we need to find this angle right here. This angle, so we call this A, so this is alpha, we call here beta, right? And this is B, right? We call this B. So to find this angle, how do we do this? We use the law of sine. So sine beta over 2 equal to sine 135 degrees over 4.64. So sine beta is 2 sine 135 degrees divided by 4.64. So you can directly do this, okay? 2 times sine 135 divided by 4.64, and that should give you 0.30487. That's sine beta. I'm looking for beta, so you need to find the sine. You take the sine inverse, 0.304787. So you take the sine inverse of this, right? And we get it's going to be roughly 17.75 degrees. So 17.75 degrees. 17.75 degrees north of east. North of east. So this is north of east. So she's going in this direction. Sorry if the picture doesn't look like this. So she went this way. She's gonna go in this direction, northeast. So 17.75 degrees north of east. Okay, so we're going to do one more problem. This is number 23. I wrote it down, number 31. Let's read this. An airplane is heading north an airspeed of 500 kilometers per hour. I think I wrote, sorry, I'm looking at the book, it's 600. Sorry about that. It's 600 kilometers per hour. Let me double check. I'll be right with you. Yes, this is 600 kilometers per hour. But there is a wind blowing from the southwest at 80 kilometers per hour. Okay? All right, so let me go ahead graph it with a, since I'm having a hard time drawing a straight line with my splint here. We have an airplane, this is the airplane here, going at 600 kilometers per hour. That's the speed. And it's heading north. This is north. Okay? Now, in airspeed, a wind blowing from the southwest. So it's going this way. Now remember the southwest, there it is. Here's southwest, so it's heading this way from the southwest. So it's going to be it's a shorter vector because it's much less, it's only 80. So this would be like this, 80, and this is the wind, right? They want to know how many degrees off course will the plane end up flying. As you know, it's heading this way, but when the wind head this way, so it's gonna swerve, you see it? It's not gonna go north anymore. Because of the wind, it's gonna be off course. So they want to know how many degrees off course will the wind end up flying, and what is the plane's speed relative to the ground. Since we're not exactly using the vectors, we're using the law of sine and law of cosine, I'm going to answer this question first. What is the plane's speed relative to the ground? Okay, so we're going to answer this question first. Now remember I showed you in vectors. So this is airplane, this is 600, right? In this direction, north. And then the wind, I can move this right here to here. You guys see this? So I can move this with the same direction and same length. So that's what I'm going to do here. This is the speed. This is the wind blowing here, 80, right? What is the plane speed relative to the ground? So we're looking at the speed here, the magnitude of this vector right here. All right? Here, just like we did in the previous example. All right, so we have to size, we don't have an angle, but do not worry, we know how to find the angle, right? Here is 90 degrees, and this is the angle. Remember, this is going southwest, so this is 45 degrees. So this is 45 degrees. So this is 90 plus 45, okay? 90 plus 45 degrees, and that should give you 135 degrees. So this is right here is 135 degrees. So remember 90 and 45. This is going southwest, southwest. And as you know, it's right in the middle. Here 45, here 45 degrees. Okay? Now we need to know this side, so we're going to find the plane speed we already have side, angle, side. So side, angle, side, we have to use the way we've done it before in the previous problem. So just as I showed you, if we're going to call this A, right, it's going to be A square, and this would be alpha. A square equal B square plus C square, the other two sides, right? Minus 2 times BC cosine alpha. So A square is just, you're going to have to just plug them in. So this is, if you want to call this B, doesn't really matter, this is C. So 600 square plus 80 square minus 2 times 600 times 80 cosine alpha is opposite the side A, which is 135 degrees. You can go ahead and directly plug this in the calculator, and you should get 600 square like this plus 80 square. You can continue. If you have two TI30X, you can do this minus 2 times 600 times 80 times cosine 135. So this 434,282.25. So A square is 434,282.25. Remember, you don't want A square, you want A, so take the square root. You should get like 659.0009. It's really 659 kilometers per hour. This is the speed of the plane relative to the ground. So this is 659 kilometers per hour. I didn't write it down, but they're kilometers. Okay. Now we can answer the other question. How many degrees of course will the plane end up flying? So remember, this is going north. It's ended up going this way. So it's going in that direction, ended up going in that direction. How many degrees of course? This is it, right? From here to here. So this is what you're trying to find here. Okay, so this is C, this is gamma. You can use the law of sine. Okay, you use the law of sine. So you have angle, side, so sine gamma, that's what you're looking for. Sine gamma over the side, opposite gamma, which is 80, right? Sine gamma over C, or 80, equal to sine 135 over 659. I'm just using the law of sine. So sine gamma is 80 sine 135, right, divided by 659. So sine alpha is, go ahead and plug it in the calculator. It's 0.0858399. This is what I got, 0.0858399. And you just use sine inverse to find gamma, and this is approximately 4.924 degrees. So the plane will end up be 4.24 degrees of course. Okay, so we're going to stop here.